Okay, so we're going to start on the, if my pen works. My pen's not working. No, I went to go all the way to the end. Okay, so we're going to start with a review of organic part B. Okay, and just because it covers pathways, remember alkanes, you're talking about a free radical mechanism. Okay, and that was with a halogen and UV light. Remember that this involves homolytic fission. Now remember that because the products kind of look the same. Each is the free radical, one electron. Goes to each half of the halogen. And then remember, you have to be able to do initiation steps. Then you have propagation. And you have termination. Okay, then we're going to talk briefly. Ooh, that's an awful color. Hang on. Okay, then we're going to talk about alkenes. Okay, and these are really going to undergo addition reactions. In particular, these are going to be electrophilic additions. Meaning your electrophile that electron seeking, electron deficient molecule is going to be attracted to that electron density of that double bond. Okay, you need to know the mechanism for that. And you also need to know and be able to explain Markovnikov's rule. All right, so if we look at the alkenes, this is not an alkene. Looking at the alkene, it's important that you know mechanism. We're going to actually, I think, look at two. Okay, so say we have ethene and we have a bromide ion. Remember that this double bond is very electron rich. Okay, high electron density. It's going to, on a nearby bromine atom, force a temporary dipole. This electron pair is going to come and make a bond with this bromine. It's important that you start there and at the bromine. This bond is then going to give its 2 electrons to that bromine. What we're going to form in this particular case is known as a bromonium ion. And a bromide ion. This plus sign is on the bromine, okay, because we're an electron pair short. The next step is this bromide, the unshared pair of electrons going to the carbon, and then we'll end up with the (1,2) dibromoethene. You may also be asked to show a mechanism where maybe we have propene say reacting with a chlorine and a bromine molecule. This is going to be a polar molecule. Chlorine is more electronegative, so this is going to be the partially negative. Bromine is going to be the partially positive. This high electron density then is going to form a bond with this bromine. That pair of electrons in that bond is going to go to the chlorine. Here's where you have to think about Markovnikov's rule and the more stable carbocation. Okay. The bromine is going to end up here, carbocation here, because it has this alkyl group on the end to have some kind of inductive stability on this carbocation. Then I have my chloride ion, that unshared electron pair going to the chlorine, making my final major product. That. Okay. So you do need to show the mechanism for the addition reactions for alkenes. For moving on to alcohols. I don't know what that is. You may have a primary alcohol. Right. If I put this into an acidified dichromate ion environment with distillation, you're going to make the aldehyde. You should draw all the H's. If I continue and change that distillation out to a reflux, that should be a 2-, to reflux, I will form the carboxylic acid. Okay, if I have a secondary alcohol, if I have reflux in an acidified dichromate environment, I will go ahead and make the ketone. If I have a tertiary alcohol, there is no reaction. Okay, next screencast, we'll start talking about halogenoalkanes.